Okay, in 11.2, we're talking about circles still, and today we're specifically going to be talking about arcs and chords. So just a reminder of what that means. A chord, we've already talked about. A chord is a line segment that hits the circle 2 times. So what I mean is here, here's my circle, a chord could go from here to here. So it's a straight line and it hits the circle 2 times. A chord could also look like something from here to here. A chord could be a diameter, but it's not always a diameter. Remember, diameter goes straight through the middle of the circle. So diameter, they put a circle or a dot there, that means that that's a center, and a diameter goes right through it. Okay, so we've talked about chords before, but an arc we haven't talked about. An arc is the outer part of the circle. So this yellow section is called an arc. So let's see, how can we define that? An arc is, we could say that an arc is an unbroken part of the circle consisting of 2 points. So we can say it's the outer part of the circle and it's unbroken, so it can't be split into 2 different pieces. So an example here is a circle. We could say that an arc is, oops, I don't know why that disappeared, is this part. Okay, we're going to be talking about arcs today, and I think that's the first thing we're going to be talking about. So there's 2 different types of arcs. A minor arc is an arc whose points are on the interior of a central angle. So you can think of a minor arc as being smaller. So for example, in this one, if we have this ray hitting it, so if we were talking about, this is the center, if we were talking about this part of the arc, this is small, it's within those 2 line segments, it's going to be minor. If we're talking about a major arc, we're talking about the bigger part, so we're talking about all this part. So a major arc is an arc whose points are on the exterior of a central angle. So here they're talking about this red segment, that's minor. Major, they're talking about all the rest of it. So you can think of a major arc as being larger. And then we need to know what a semicircle is. Some of you guys can take a guess. Semi means half of a circle. And it's really important that you remember that a semicircle will always be 180 degrees. Because if you think about it, this is a straight line, and we know that straight lines are 180 degrees. So in your own words, write down what you think the difference is between a minor arc and a major arc. Oops. Okay. So what we're going to do, the first thing we're going to be doing today is reading circle graphs, which some of you guys will think is a breeze, and some of you guys are like, I know I learned this somewhere, but I can't remember. So here it reads that the circle graph shows the types of grass planted in the yards of one neighborhood. Find measure of KLF. Right? Is that what they wanted? Yeah, they're talking about arcs here. Pretty sure. Let's see. KLF. KLF. Yeah. So if you look at this arc, KLF, K, we're going to go from K, then we're going to read to L, then we're going to read to F, because that's where it's telling us to go, from K to L to F. So the cool thing is that since J is in the center of the circle, which they'll tell you, I didn't, and that's my bad, they'll tell you in circle J, and that means that J is the center. So if J is at the center and these 2 points, these are radii, JF and JK, then that means that the arc is going to equal the central angle measure. So what that means is if this whole thing is 65%, then that's going to be 65% of the whole, of the whole circle. So all you have to do is say that it's 65% of the whole circle. And what do we know about a whole circle? Well, if a half a circle is 180 degrees, then a whole circle is 360 degrees. So you can't just go 65 times 360. You need to change this into a decimal. And to change it into a decimal, you move it over twice. So really, you're going to go 360 times 0.65. And that's going to tell you what that part of the circle is. 0.65 times 360. And your answer should be 234 degrees. The final answer. Okay, same thing for here. Find arc, measure of arc FG. And if you notice, this one only has two letters instead of three. If you look at the difference between a minor arc and a minor arc only has two letters because it's telling you it's smaller. A major arc always needs to have three, and that tells you that you need to go around and it's going to be bigger. So you're looking at this one, major arc or minor arc FG. So we're only looking at this part this time, and that part says it's 20%. So we just need to do 20%, which is 0.20 times 360, and that'll be what that is. So 72 degrees. Okay. And then, so why don't you go ahead and finish 3 and 4, and I'll check those tomorrow in class. Okay. The other thing I could ask you for are for angles. So, for example, if I wanted you to find measure of angle FMC. Okay, let's look at where FMC is. Here's F, here's M, and here's C. So what they want us to find is this angle. And remember what I told you. This highlighter isn't really awesome, but we want to find this whole angle. And remember what I told you is the central angle is going to be the same as the percentage or the arc. Okay, so here we know that pop makes up 9%, country makes up 10%, and R&B makes up 11%. And those are the only three pieces of the pie that we're really talking about. So this angle is going to be the exact same thing as the degrees, which is what we were doing up here. So over here we were finding arc lengths. Or the measure of the arc. So for example, measure of FG, this was really, we would call it 72 degrees. In terms, it's 72 degrees out of the whole 360 degrees. It'd be the same thing as saying that this angle is 72 degrees. So this angle is 72 degrees and this arc is 72 degrees. So for 5 and 6, when they want the angles, all we're doing is the same exact thing. They want to know, instead of the arc, they want to figure out what this central angle is. And it's a central angle because M is at the center of the circle. So we have 9%, 10%, 11%. All we have to do is add those up, 9 plus 10 plus 11, and we get 30. Plus 9 plus 11, I'm sorry, 30. Okay, so we have 30% of the entire circle. So that means just what we did yesterday. We take the percent, we multiply it by 360 because there's 360 degrees in a circle, and we get 108 degrees. So let's think back at this. 108 degrees. We're saying that this angle is 108 degrees. Does that seem about right? This does look like an obtuse angle to me, so I'd say 108 degrees is absolutely the correct answer. So you're going to do 3, 4, and 6 on this page, and I will check it tomorrow. And now we're going to go on to the second thing. 3, 4, 6. Okay, the second thing, using arc addition postulate. So arc addition postulate is so similar, if not the exact same thing as what we did all the way back in chapter 1 with the segment addition postulate. Segment addition postulate said if we have a segment, a line segment, and I told you that this segment was 1 and this segment was 2, how long would the whole segment be? It would be 3. All you had to do was add them up. Same thing with arcs. Super cool. So if I wanted to find what measure of arc ABC was, so ABC, all you'd have to do is find out what AB is and what BC is. So if I told you that this arc was 2 degrees and this arc was 1 degree, then that means our answer would be 3 degrees. Something really important to remember, semicircles. So if you have half of a circle, and again, they have to tell you that this is a diameter, so it could look something like this. This is always going to be 180 degrees. If you have a whole circle, it's going to equal 360 degrees. And that'll help you guys out sometimes. Sometimes it's easier to look at circles and semicircles and not adding up different parts of the arc. Okay, so for 7, Find measure of a minor arc BD. So BD means we're going to take the shortest, since they only give us 2 letters, we're going to take the shortest path from B to D. I don't know why all that came down with me. Okay, erase. Okay, so the shortest path from B to D is here. So what we're going to do is look at all this information. Notice that they tell you clearly that F is the center of the circle. So what that means is this BE is a diameter. So what that means about this part is this whole thing is half of a circle and equals 180 degrees. So I'm going to write that major arc BCE equals 180 degrees. That's half of a circle. And I know that arc ED is 52 degrees. So if I take this and subtract it, I can get what arc BD is. So all I have to do is subtract the two and I'll get my answer. So 180 minus 52 is 128 degrees. So measure of arc BD equals 120 degrees. And that's my attempt at an arc right there. Okay, so sometimes, like I said, it's easier to look for semicircles and whole circles rather than necessarily adding up arc measures. Okay, so let's try number 8. Number 8 says find measure of major arc AEC because there's 3 letters. So we're going to take the long way around. A to E to C. Let's look at this. F is in the center, which means AC is going to be a diameter. So isn't this just half of a circle? Yes! So your answer is just going to be 180 degrees. Okay, let's see if we can do some harder ones. Number 9, find measure of minor arc LN because it's only 2 letters. So L to N, the shortest route is going to be this one. Well, we know that that is going to consist of arc LM, measure of arc LM, plus the measure of arc MN. And we already know what those numbers are. LM is 40 degrees and MN is 25 degrees. So all we have to do is add them up and our answer is 65 degrees. Okay, I'll do one more with you and then you're going to do 11, 12, and the reflection and we're done with this with notes for today. Okay, so measure of major arc JKL. JKL. Let's see, so we're going to take the long way around this time. JKL is from J to K to L. Okay, so we don't have anything to add this time, so we need to look for semicircles and whole circles. So if you look at JM, that is a half of a circle. So that means that it equals 180 degrees. And we know that this arc is 40 degrees. So if I get rid of that 40 degrees, I'll have the leftover, which is what I want. So I'm going to subtract 40 degrees from it, and my answer is going to be 140 degrees. So this is 140 degrees plus the 40 makes a whole 180 degrees for the semicircle. Okay, so your last thing you're going to do is 11, 12, and reflection number 1, and we're done with arcs and chords and minor arcs and major arcs for today.